This video will cover sections 8.2 and 8.3, multiplying polynomials. In 8.1, we talked about adding and subtracting polynomials, so now we're going to multiply them together. So you do not have a handout for these notes, you're just simply writing them down. So sometimes you might need to pause to write something down, the video, before you listen to the instruction. So when we multiply polynomials, I first want to review the distributive property. We've learned this before, so we've actually multiplied polynomials before. We're just going to look at it in more extent today. So just a review of the distributive property. So a lot of times you'll see parentheses, and you're going to distribute what you see in front of the parentheses. So here we have 3 times x plus 2. So that 3 gets distributed to both things inside the parentheses. And remember, distribution is multiplication. So 3 times x is 3x, and then 3 times 2 is 6, and then that's simplified. So that's my answer. So again, we're just simplifying expressions, which means we're getting rid of parentheses, we're combining like terms. All right, so now we're going to take this to just a little bit of a bigger level. And so for our first example, we're going to multiply these using the distributive property. So now instead of just 3 in front of the parentheses, I have a 3 and a variable y. So that whole thing, 3y, gets multiplied to both y and 8. So now that we've learned our exponent rules, we have 3y times y. Now, think about the coefficient of that y is just 1. So the 3 and the 1 get multiplied to be 3. And then y times y, that gets squared. So that's 3y squared. Then the 3y gets multiplied by, be careful, negative 8. So 3 times negative 8 is negative 24y. Now these are not like terms, so this is my final answer. They cannot be combined. Okay, so for the last one, we're making it a little bit more complicated with what you see in front, and that is the negative 2x squared. This whole thing, including the sign in front, get distributed inside. So that's negative 2x squared times 3x. And if you want to think of x having an exponent of 1, you can. So then we'll have negative 2 times 3, which is negative 6. And then for the exponents, you have x squared times x to the first. So what we're doing is we're multiplying like bases. So when we multiply like bases, we want to add the exponents. So that would be negative 6x to the third power. Then the negative 2x squared gets distributed over to the negative 7x to the fourth. So we have now negative 2x negative 2 times negative 7. And that would make a positive 21. And then again, you have x squared times x to the fourth. And when you multiply those together, you add their exponents to get x to the sixth power. So again, when I multiply, you multiply the numbers in front, and then you add the exponents. These are not like terms, so this is the final answer. So in example 1, we did not have any like terms to combine, but in example 2, you see that I said multiply and simplify. So we're going to multiply first, and you see we have 2 parentheses, so we're going to have to distribute 2 separate times. And then we are going to simplify by combining like terms. So the first one, I distribute the x. So that's x times x is x squared. Then x times negative 1 is negative x. Then over here, I have the plus 5, which gets distributed. So I circled the plus because if that was a minus, you'd have to pay attention and change the signs. So plus 5 times x is plus 5x. And then 5 times negative 1 is negative 5. Now you have to look for like terms. So x squared, there's no other x squared, so that's just going to stay x squared. And then you have a negative x and a positive 5x. Those are like terms, so we can combine them. So negative 1 plus 5 is plus 4x, and then minus 5. Those are not like terms, so that is my final answer. Okay, so for my final example, we're going to do the same thing that we did in part A. So actually want you to pause the video and solve this out yourself, and then when you unpause it, I'll have the answer written out. And actually on this one, once you multiply those, there's actually no like terms here. So what you would first write down is your final answer. I do want to make sure and mention that with the -4 here, that you multiplied the negative through by the positive, so then you would have a -12 there. Okay, so we're going to make this a little bit more challenging. So for example 3, I'm going to introduce a new type of distribution to you, which I like to call double distribution. All right, so as you can see in example 3, the difference with example 3 is I now have 2 sets of parentheses instead of just the 1. So what's going to happen here is I'm going to have to double distribute. Because if you think of this a squared plus 1 as being in front of a plus 2, then that gets distributed to everything inside. So what I like to think of is I like to look at my first parentheses and the first term in the first parentheses. Okay, so I'm going to ignore the 1 for a second. That a squared is going to skip over into the next parentheses, and it's going to distribute into those 2 things inside the second set of parentheses, just like we did with the first 2 examples. So again, I'm going to ignore the 1 for now, and I'm going to distribute that a squared. So a squared times a would be a cubed. Then a squared times 2 is plus 2a squared. All right, so that's the first step. Then the second step, and I actually wanted to move that down a line so that I have room to show the second step. So sorry that you already wrote that. But the second step now is I skipped over that plus 1. So now think of this as the 1's turn. So this is where the double distribute comes in. I've distributed the a squared. That's my first distribute. Now my second distribute, the 1 gets distributed also. So it's going to distribute, it's going to skip over and distribute just like the a squared did. Okay, so that also gets a chance. So then 1 times a is plus a, and then 1 times 2 is plus 2. So then I look for any like terms. I don't have any like terms. It's written in standard form with descending exponents. So this is my final answer. And we'll get practice with another one of that double distribution. Okay, so number 2, or part B. So again, I'm going to double distribute. So I want to look at the very first term that I see. And remember, I know that this is double distribute because I see 2 sets of parentheses that are being multiplied. That's important. We're not adding like terms. We are multiplying here. So it's a little different. So that 2y is going to skip over the 1 into the next set of parentheses and distribute there. So that's going to be 2y times y is 2y squared. Then 2y times -7 is -14y. Then the next term is plus 1, and it gets distributed to everything inside. So 1 times y is just y, and 1 times -7 is -7. Now, if you look here, these actually do have like terms. So you have -14y plus 1y, so those are going to simplify. So this whole thing will complete down to 2y squared, -14 plus 1 is -13y, minus 7, and that is my final answer. Now, a lot of math teachers show this double distribution in a different way, kind of like a graphical organizer. So if you're a visual learner and you like to kind of have things kind of spatially graphed out for you, then I'm going to show a different method. So I want you to kind of be familiar with both, and then I think you'll find that you like one or the other. I'm okay with you using either one when you actually do this for practice. So let's look at the next example. So the first method for this multiplying these 2 things is called double distribution. The next type is called like the box method, or using a divided box. Okay, so we're not going to use the double distribution. We could definitely do double distribution, but I'm not going to do this for this example. So I'm going to draw a box. All right, so draw a big box. It could be a square, and I want you to divide it into 4 pieces. Now you have the x plus 3 and then the x plus 4. So what you can kind of think of this as like you're finding the area of a box, and you find the area of a box or a rectangle by length times width. So if you think of the x plus 3 as this side length, so I'm going to split this up into its pieces, into its terms. So the first term is x, and the second term is plus 3. So I'm going to write that on the side by splitting that into 2 different side lengths, x and then plus 3. And then across the top, I'm going to split the x and the plus 4 up. So now what you've kind of created is kind of like a multiplication chart like you did when you were first learning your multiplication tables, and you kind of go across. So in this box, that would be the x times the x. So then you would fill in x times x in that box would be x squared. Then in this box, you would look up the 4 times x. So 4 times x is, oops, hold on, sorry guys, is 4x. And then in this box, you would look up to x over to 3. So then that would be 3x. And the last one up to 4 over to 3. And so that would be 4 times 3, which is 12. Okay? So I know it kind of looks weird at first, but you're just looking up and across to see what the 2 outer terms are, and you multiply those together. Now, when you put this all together, you can see that 2 of the boxes have like terms in them. So that's the 4x and the 3x. So what you're doing is you're going to be adding all of these terms together. So you would write them in descending order. So x squared would come first, then plus 4x plus 3x, and then plus 12. And if you wanted to go ahead and say, okay, I know 4x plus 3x is 7x, you could go ahead and write that. So that is the answer. Okay, so I'm going to show you that one more time because I know it's kind of confusing the first time you see it. All right, so I have 2 binomials, right? They're 2 terms of a polynomial that are being multiplied together. So I want to have n minus 1 kind of go down the side. So I'm splitting up my terms, and so my box will look like that. Then across the top, I have 4n plus 5. So that's being split like that. So you're going to have a square because it's a binomial by a binomial. So it's going to be like a 2 by 2 square. All right. So now we're going to multiply. And so in this box, that's 4n times n. So that's 4n squared. In this box, 5 times n is 5n. In this box, negative 1 times 4n, which would be negative 4n. And in this box, positive 5 times negative 1 is negative 5. And now you just write all your terms together as a polynomial. And also you can see that there's your like terms that will be added together. So if I want to write this, you would get 4n squared, then 5n minus 4n is 1n, and then minus 5. So you can kind of see 5n minus 4n is positive 1n. If you need to write out the second step, that's totally fine, like I did up here. Okay? All right, so again, just to recap, we are multiplying polynomials together, and we're actually multiplying binomials. So 2 terms times 2 terms. So in example 3, we did double distribution. In example 4, we did the box method, and you'll get the same answer either way. Okay, so for example 5, we're going to take a binomial and we're going to square a binomial. So for example A, we have the binomial n plus 3, and that's being squared. And we're going to solve this one by doing double distribute. Now, the first thing that I want you to make sure and understand, and actually don't write this down, okay? I'll be checking in your notes. Don't write down what I'm about to write down in green, okay? Then we'll pick back up. This is not equal to n squared plus 3 squared, which is 9. Okay? You cannot square both of those things because what we're doing is we're adding n and 3. So you cannot square both of those things. Okay? So that is never, ever, ever the answer. So don't ever square both of those things. So I'm going to see if you heard me on that. All right, so now what we have to do in order to do this problem, we have to write this out as n plus 3 squared. So that's n plus 3 times n plus 3. And now it becomes the same type of problem that we did in example 3. So we are going to do A like double distribute. So that's n times n and n times 3. So that's n squared plus 3n. And then our double distribute means we're going to distribute positive 3. So we get plus another 3n, then plus 9. So what happens is these like terms come together, and we're left with n squared plus 6n plus 9. And remember at the very beginning, I said that it was not equal to n squared plus 9. Okay, because you can see right there, you've got that 6n. Okay? All right, so now we're going to do the same thing, but with the divided box. All right, so for part B, we have another squared. And so whenever you see a binomial that's being squared, you want to write it out as two things being multiplied together. All right, and so I'm going to do the box this time. So 8p minus 2. It's a binomial times a binomial, so that's going to be a 2 by 2 square. And now multiply. 8p times 8p is 64p squared. 8p times negative 2 is negative 16p. Negative 2 times 8 is negative 16p. And negative 2 times negative 2 is positive 4. So again, you can see these middle terms here are going to add together. So this answer will be 64p squared. Negative 16 and negative 16 make negative 32p plus 4 is my final answer. Okay, so again, binomial squared, you have to write it out into two things. Okay, this is going to be our last example. So for example 6, we're going to multiply a binomial times a trinomial. So far we've been doing binomial times binomial. So now if I have a binomial times a trinomial, it's the same exact thing, you just have to do one extra step. So for double distribute, it's still going to be double distribute. So you see my first thing is 3y, and it gets distributed, but now this time I get distributed to a trinomial, so that means 3 different things. Okay, so 3y times y squared is 3y cubed. 3y times negative 5y is negative 15y squared. 3y times 7 is plus 21y. Now I need to do my second term, and I forgot to leave space, but that's okay. So now I'm going to distribute negative 4. So negative 4 times y squared, negative 5y times 7. So remember that negative there that I circled. Make sure you don't forget that. So negative 4 times y squared. Negative 4 times negative 5y is plus 20y. Negative 4 times 7 is negative 28. Now you need to look for like terms. So 3y cubed, there is no other cubed. Negative 15y squared minus 4y squared would be negative 19y squared. Then I have 21y plus 20y, which is plus 41y, then minus 28. And that is my final answer. So I know I said one more example, but there are 2 parts, so we're going to do one more with the binomial times a trinomial, but as a divided box. So since I have a binomial times a trinomial, this is going to be a 2 by 3 box. So a little bit of a bigger box than we had in the previous examples. So I'm going to have 5m and negative 1. Then in the top 2m squared plus 3m and negative 7. Now, I'm going to let you fill out the box by yourself, and then we'll come together and put it all in one expression. Okay, so here's the box filled out. Hopefully all of those make sense. I just multiplied what was above it and what was to the side of it. Now, with this box, you can see that my like terms are kind of diagonal of each other. So there's my m squareds that are like terms, and then my regular m's that are like terms. So 10m cubed stays alone. Then 15m and negative 2m squared would make 13m squared. So that goes here. And then negative 3 and negative 35 make negative 38m. Goes there. And then plus 7. So those are all my like terms combined. Okay? So that's just the beginning of multiplying polynomials.